Hello. Today we're going to talk about 9.4 Arithmetic Series. Okay, so a series, how it's different than a sequence, is you're adding them all up to get one number. Okay, so you have a finite sequence, which is right here, it's just a list. A finite series is when you add those numbers up. So an infinite sequence would be like this, and notice it has the ellipses, or three periods at the end. And then an infinite series would be when you're adding all those numbers up. Okay? Well, there's of course a shortcut, just like we did in the other videos. So what's the shortcut? How do we add these up? Okay, so let's take the first term and the last term. Just go with me here. You get 18. Notice the second and the second to last is also 18. Then 7 and 11, the sum is 18, and 9 is just half of 18, right? So here we have 3.5 18s. So we can write that as the sum, so it's a capital S, and then a subscript of 7. Sum of the first 7 terms would be, well, 3.5 times 18. All right, well, what's another way of writing that? 3.5 is just 7 divided by 2. Okay, so notice what we have here. 7 is how many terms there are. 18 is the sum of the first and the last. So our formula is just this. So the sum of the first n terms, so 7 terms, 5 terms, 100 terms, you do n over 2 times the first term plus the last term. All right, another way of writing it, okay, is through sigma notation. Okay, so the summation sign, or sigma, okay, sigma notation is that kind of like a capital E. So I'll start with that so you can draw it with 2 parallel lines and then do a greater than symbol. Okay, if you want, you can go back and add the little pieces. You don't have to, but that's the sigma. All right, the upper limit would be 20, all right, because that's the high end. The low end is underneath the sigma, so that would be 1. And then the general term is the thing to the right. So the general term is 2n. Okay, I get kids that mess up sigma notation all the time, but you're gonna keep seeing this. Okay, it's gonna come back, so get familiar with it. Let's do some examples. So here we want to find the sum of the first 40 terms of this series. Well, remember your formula. All right, so we need these things. Well, n is the number of terms, so we have 40 terms. The a sub 1, or the first term, is 2. But now we need a sub n, so that's the 40th term. Well, I don't have that listed. So think about how you find the 40th term. Well, it's arithmetic, so that's the first term plus the difference times n minus 1. That was in video 9.2. So here we would take the first term plus the difference. Okay, we get the difference by doing 5 minus 2 equals 3. The second term minus the first term. And then 40 minus 1. All right, so then we have 2 plus 3 times 39. Let's see, and that should get us 119. So now we have all of our information, the 40, the 2, and the 119. So to find the sum of the first 7 terms, what did I say, 7? I'm still in the last problem. 40. 40 terms. 40 over 2 times 2 plus 119. All right, we get 20 times 121, so we get 2,420. All right, now let's look at it in sigma notation. So if I want to find the first term in sigma notation, we start with the lower limit and we plug that into our general term. So 5 times 1 plus 2. So we get 7. If I want to get the next term, okay, make k equal 2. So we get 5 times 2 plus 2. That gets us 12. Plug in 3 to get your third term, right, because we started with 1. So 5 times 3 plus 2, 17. All right, hopefully you're starting to see a pattern here. Okay, so this is an arithmetic sequence. And we start when k is 1. All right, so this is our starting point. And we go until the upper limit. This is our stopping point, our ending. So we would keep going and plug in 20 to get our last term. So that'd be what, 102? So now we have everything we need to get our sum. We could do every single term and then add them up, but that's really time consuming, right? Notice that this is arithmetic, so we can use our formula, right? This one over here. So the sum of the first, well, we're going from 1 to 20. So there are 20 numbers from 1 to 20. N over 2, so 20 over 2. The first term plus the last term. All right, we plug that into our calculator. Let's see, and we should get 1,090. All right. So hopefully you're getting comfortable with just plugging stuff into the formulas. Okay, so let's step it up a notch. So here, we want to find the first 3 terms. Well, we lucked out, we got the first term. We only have to find 2 more. So let's think about this. A sub n, we know that equals 100. Well, a sub n is also a formula. The first term plus the difference times n minus 1. Remember, this is arithmetic. And s sub n also has a formula. So why don't we plug in our a sub 1, our first term, into those equations. And we know the nth term is 100, so we get 100 equals 5 plus d times n minus 1. S sub n would be 1050 equals n over 2. And we've got the first term and the last term, 5 plus 100. Well, I can't finish the one on the left because I've got 2 variables left. But the one on the right, this one I can do. So let's work it out. Let's see, I'd multiply this by 2, so we get 2100, and this would be n times 105. Then, let's see, you divide by 105. That's going to get you 20. So there are 20 numbers. So now let's go ahead and plug that in there. I'm going to move the 5 over as well. So the difference times 20 minus 1. So now we just got 95 equals 19 times the difference. So the difference is 5. Well, it said the first 3 terms. The first term is 5. The difference is 5. So just keep adding 5. There are your first 3 terms. Okay, let's do number 5. Find the sum of the first 50 positive integers. Okay, the the first 50 would be, well, 1 plus 2 plus 3 plus 4. And we can keep doing that all the way up to 50. But again, that takes a while and you might hit the wrong button on the calculator. So use your formula. It's the sum of the first 50 terms. So we do 50 over 2 times the first term plus the last term. So really we have 25 times 51, so our answer is 1275. Okay, it looks scary, but it's not. Okay, you just got to understand what it's asking you to do. All right, definitely got to practice more sigma equations. So try these. Number 6 is tricky though. All right, what usually happens with number 6 is people don't notice this one starts at when k equals 3. So we do when k equals 3, k equals 4, k equals 5, k equals 6, k equals 7. I have to write this out because people don't believe me when I tell them how many terms there are between 3 and 7. Okay, all the time kids tell me, oh, well that's just 7 minus 3, and they say there's 4 terms. Oh, but you got to count the 3. Because see, 1, 2, 3, 4, 5. So when you want to find the number of terms, you want to take the upper limit, subtract the lower limit, and add 1. Okay, so take the upper limit, subtract it. I don't like how I wrote that. Hold on. There we go. That's much better. Upper limit minus the lower limit plus 1. That's how many terms there are. So here it would be 7 minus 3 plus 1. So notice that would be 5 terms, and that's what I have here. Okay. Again, this is why I get some kids that just literally plug in all the numbers and then add them all up. They try to just keep it simple. Okay, but I like using the formulas. So let's plug in the first one. When we plug in 3, we get 2 times 3, which is 6, plus 5 is 11. If you plug in 4, you should get, what, 8 plus 5, so that's 13. All right, plug in 5, you're going to get 15, 17, and 19. Okay, I don't need to get 16 because I could just use the formula, or you can just straight up add this. Okay, I like to double check everything as I go. So the sum of the first 5 terms is 5 over 2 times 11 plus 19. All right, we plug that in our calculator, we get 75. Okay, let's do this one. Number of terms is 6 minus 1 plus 1, so we get 6 terms. So the sum of the first 6 terms is 6 over 2. Plug in the first term, we get 10. Plug in the last term, we get, what, 25. We work that out. Let's see. So we get 3 times 35, 105. I don't know why I said that like a question, like I'm going to hear you answer. All right, but that's how we do it. Hopefully this is making sense. If not, just please talk to me in class. All right, so let's work backwards. Let's try to write this in sigma notation. So for number A, we are going to, I'm going to keep it really simple. You could mix it up and do it all crazy, but why do that? That's insane. Keep it simple. Do 7 is the first term, and 700 is the last term. Okay, we have no idea how many terms there are. So let's figure it out, right? We know to get the nth term is this formula. So plug in what you know. You know the first term is 7. The difference is just 7. And this is where people mix up. 700 is not n. You're not looking for 700 terms. 700 is the last term, so it goes here. And you solve for n. Okay, so we have 700 equals 7 plus 7n minus 7. All right, so we work that out, and you get 100 equals n. So there are 100 terms in this sequence. So if I want to write it in sigma notation, we're going to start when n is 1, a sub 1, and go to the 100th term. Now, we need the general term. So the general formula is this. General formula. Ooh. So we plug in what we know. We know the first term is 7, the difference is 7, and it's this. We can simplify it, make it nicer, right? We just get 7n. So that's the term. That's how you get the term. So this is your final answer. Let's do number 9. So here we're starting with a sub 1. Here you're going till infinity, right? Until forever. Okay? So when we do our sigma notation, we would start when n is 1 and go forever. All right, so now notice what's happening here. Okay, it's not arithmetic anymore. This is a geometric. All right, so how do we find the nth term of a geometric? Well, plug in what you know. Oh, what am I doing? Plus, oh, good thing I caught it. My goodness, it's multiply. Silly me. So our nth term would just be 5 times 2 to the n minus 1. That's our general form. So just leave it like that. There's nothing else to simplify. All right, so once you practice these two, pause it, give it a whirl. All right, so number 10, we have the first term, the last term. So we have this formula. So that means 207 equals 7 plus, we're adding 4 each time, n minus 1. So 200, 4 times n minus 1, 50 equals n minus 1, 51. All right, so our sigma notation is when n is 1 and we go to 51. Our general formula was just right here. Well, I'm sorry, 7 plus 4 times n minus 1. So we have 7 plus 4n minus 4, so 4n plus 3. Okay, now let's try 11. We have our first term and our nth term. Another arithmetic. So we get, let's see. Okay, so we get 268 equals negative 5 plus our difference, which we are adding 7 each time. All right, we work that out. Let's see. I'm just making sure it's right. Okay, so 39 equals n. So now for our sigma notation, we start when a equals 1, not when a, when n. My goodness, I'm all over the place. So when n equals 1, all the way to when n is 39, we're going to add up all those numbers. So that would be this formula, but we can simplify that. Negative 5 plus 7, n minus 7, 7n minus 12. Okay, if you have any questions, come just ask me in class.